First thing, thank you for all of you joining us here, and a special thank you also to the people that has made this conference a real thing. Today we're going to talk about design a contract in Elixir, where the airline motto, let it crash, meets it shouldn't crash. We're going to see why and how. So my name is Elba Sanchez. My partner here is Guillermo Iguaran. We are coming from a city in the Caribbean coast of Colombia. We work in a startup named Ride that is based on New York City. What we do on Ride is trying to make commute better by having less cars in the road, and lowering the cost of commuting, and also helping environment. We use Elixir in our daily basis on notification systems, location systems, and right now we're building a chatbot, which is really cool. So how did we get here? Bugs and crashes. We deal with them every day, and we try to avoid having them. Just like Dilbert in here that made a client test his software, but it sadly burned her app. So in his defense, that hardly ever happens. So what maybe Dilbert did was he missed an edge case when he was writing his tests.
Sorry, can I just quick interruption? It's hanging against your matrix breakpoints.
Thank you. Is this better? Yeah, he missed an edge case on his test. So, did you all know that there are really expensive software errors, also mortal errors, but we're not getting this dramatic, such as the NASA Mars climate orbiter, the Ariane's 5 flight 501, who both crashed. The Heathrow Terminal 5 opening that left all those bags hanging around them. The Mariner 1 spacecraft that also crashed. The Morris worm that infected thousands of computers, and the night errors that costed nearly $440 million. So that's a lot of money. For this talk, we're going to take the Ariane's 5 flight 501 as an example. In 1996, 500,000 software error caused the crash of the maiden flight of the Ariane's 5 European launcher. The Ariane's 5 faster engines exploded a bug that was not found in the previous models. The rocket reused working software from one of its predecessors, the Ariane 4. So 36 seconds later, after launch, it crashed. Why? The software had tried to cram a 64-bit number into a 16-bit space. So in other words, the value that was converted was greater than it can be represented in a 16-bit sign integer. So there was no explicit exception handler, so the uncaught exception went through his normal flow, crashed the system, then crashed all the onboard computers, and it hence crashed the entire mission. So this kind of trivial error is an error that we are all familiar with in our daily basis. But fortunately, the consequences for us are not usually that expensive. So, and the Ariane 5 team made a research on why this happened, and they wrote a postmortem about it, and they say, you cannot blame management. Something clearly went wrong here, but in this case, the issue is technical. You cannot blame the language either. They were using Ada, and the exception mechanism might not be the best in this language, but in this case, not all the conversions were protected. You cannot blame the implementation either. What they did was they removed the conversion protection in order to achieve performance, which was criticized, but it was justified in theoretical analysis. You cannot also blame testing, but because you can always test more, but you can't ever test all. And testing shows the presence of errors, not their absence. So you can try to blame the fact that they were reusing software from another model, but you have to blame the reuse specification itself. Because the requirement that the horizontal bias should fit in a 16-bit was somewhere in the mission documents, but you could not find it in the code itself. So this was unacceptable in the case of the absence of any kind of precise specification associated with this reusable model. So we're going to pause here the Ariane's case and start with a little bit of design by contract theory. And also with a little bit of history. Design by contract has its roots in formal verification, formal specification, and the Horst logic. In 1962, Horst described the representation of invariants and abstractions functions to prove correctness of abstract data types. The pre- and post-condition technique was also first used by Horst in these papers, and then the term was coined by Meyer in the design of the Eiffel programming language. In fact, the current owner of the trademark design by contract is Eiffel software. We need a little bit of the basic of Horst logic because it is the core of the didactic approach of the design by contract. So for this presentation, we just need like the first paragraph, that is formal reasoning about program correctness using pre- and post conditions. This means if we start with a state where P is true and execute C, then C will terminate in a state where Q is true. So contracts, as in daily life, are a set of specifications that covers mutual obligations, benefits, and consistency constraints that a software system has to meet. So it falls under the implementation design. And we can typically try to compare it with testing, but we know that tests are to verify the software works correctly under certain sample cases, but it's almost not possible to test all the edge cases during development. So we like to say that design by contract is a software correctness methodology that documents and programmatically assert the change in state caused by a piece of program. Back to Ariane's case, maybe this piece of code that is written in an Eiffel version, which has a contract saying that the horizontal bias should not be greater than the maximum bias, could have done something to make the launch differently. But does it mean that the crash would automatically have been avoided by having the mission use a language and a method supporting building assertions as designed by contract? That's a bold thing to say, but maybe. So in humans affairs, this is an illustration of a contract between an airline and a customer. View this relationship between them as an agreement in expressing each party's rights and obligations. So for me as a passenger from coming from Barranquilla to here to Berlin, I had to buy an airline ticket if I were doing it online. Then bring accepted baggage to the airport and be 2 hours before. And my rights as a passenger will be to reach the destination. And so my obligations as a client must ensure preconditions, and my rights as a client may benefit from postconditions. So for the airline, their obligation is to bring the passengers to destination, and they don't need to carry passengers who are late or that has unacceptable baggage or hasn't paid the ticket. So the supplier's obligation must ensure postconditions, and the supplier's right may assume preconditions. So what are these preconditions and postconditions? They're the structure of a contract. So a precondition, usually the requires clause, and the postcondition, the ensure clause. The precondition characterizes the responsibility of the program that calls the method, and the postcondition characterizes the responsibility of the program that implements the method. So if the precondition is true when a method is called, then the method will terminate, return the calling program, and the postcondition will be true after this. And if the precondition is not true, then it will do nothing. So here's another example of a piece of code written in if-else. It's a routine called put that inserts a value in a dictionary, and then we retrieve it later through a key. So the required clause introduces an input condition or a precondition, and the ensure clause introduces an output condition or a postcondition. Both of these conditions are examples of assertions or logical conditions, or a contract clause, if you want to call it like that, that are associated with software elements. And the precondition, the count is the current number of elements, and the capacity is the maximum number. And in the ensure clause, has is the Boolean query that tells whether a certain element is present, and then the item returns the element associated with a certain key. So how can all this theory about design by contracts can help? So we, as developers, look for something while writing our programs. Quality. When quality is pursued, productivity follows. But we also look for stuff. Right now, for this stuff, we look for reliability. There are two parts of reliability that I highlight, correctness and robustness. And correctness is like the basics of the base and the main part of design by contract, because correct software does what it's supposed to do, and that's it. For example, if I want to check online my balance in my bank account, I should be able to do it without the transaction making my balance reduce or increment. And the robust software acts acceptably in cases it cannot do what it's supposed to do. So also the assertions, preconditions, and postconditions can be automatically turned on during testing just with a simple compiler option. Errors might be caught in. And assertions can also remain turned on during execution, triggering an exception. And most important, assertions are prime components of the software, and it automatically produces documentation, which is awesome. So, for language support, there are several implementations of library for design by contract for some languages, such as C++, C#, Java, JavaScript, PHP, Ruby, between others. And languages with native support of design by contract like Ada, Clojure, if-else, and Racket. So what are we doing to achieve something like this in Elixir?
Hello. Okay, so you can say she mentioned a lot of language, and right now there is nothing in Elixir, and I think there is nothing in Erlang. I was researching a bit, we don't find library for Erlang or Elixir to support design by contract. So that's why we decided to build one for Elixir. How? For Elixir, we rely a lot in metaprogramming, using mainly macros. Some of the rules about macros, the first rule about macros is don't write macros. Why? Macros are basically codes that generate codes. So you need to have that extra grade of, you need to be very careful to not do something strange or you know. Yeah, because macros can make the program very difficult to understand. And the second rule is that you must use macros. Why? Because maybe it's too hard when you are studying, but macros can be very useful if you learn to use it correctly. And it can be very useful in cases like this. But what are macros? Macros are basically, a macro is a code that writes codes. How is that? In Elixir, you can write code that is executed during the compiling phase. What is this? The code runs before the program is compiled and not during the runtime. So you can write code that modifies the abstract syntax tree of the language, modifying the behavior of the application. And how this is useful for us. So, well, if you want to learn more about macros, I recommend that book of Chris McCord. It's very good. It's a very good introduction about how to use macros in Elixir. Yeah, it's very, very useful. But talking bad about design by contrast, we will use Elixir macros to extend the language, adding support for some constructs to support design by contrast. So we will add a construct for requires in the language and another construct for the ensures in the language. And the macro basically will work modifying an existing function, adding the precondition, and the precondition will be executed before the body of the function, and the postcondition will be executed after the execution of the function body. It's something like this. So for example, in this example, we have a square root method that results a number as argument, and with that, require precondition. For the square root, we require that the number must be greater than 0. And we require and we can add also a postcondition saying the number must be in a certain range. So, like you can see, this is a bit like the pattern matching. Yeah, you can, for example, pattern matching that one number is in less than 0, but in contrast, you can add some kind of complex conditional that you can add in when you are doing pattern matching or when you are using words. So that's basically how the contrast looks right now in the library that we haven't built. And now let's see if working, if it's working. No. So aquí in this example we are modeling we had a model that for a tank of water. So we had a function to fill the tank with water. As precondition for the function fill, we are requiring first that the tank is not full already, so we can fill it. And we are asking also that the in valve should be open and the out should be closed. And as postcondition, we are adding that the result of the function should be the tank full, and the in valve should be closed and the out valve should be closed also. And we have another function that empties the tank. So in this other function, we are requiring that both the in valve should be closed and the out valve should be open, so the water can be empty. And as postcondition, we are adding that the result should be the tank empty and both of the valves should be closed. Okay, first we will try to run this test. In this test, we are creating a new tank that has the full level of water, but it doesn't, the in valve isn't open. So we will run this test. Okay, the way is this one. So it says that the precondition is not met. So it's a follow of the client that is using the function. So let's back to supply. Where is supply? Okay, so we are using instead a tank that fulfills the precondition. And let's run the test again. Let me see.
Like 20 lines. You have space before end, roughly. This is like one chart.
Yeah.
20 lines. There's space before end. Maybe this is like one chart.
One here.
20. Just guessing. But some charts are not visible in UTF.
Yeah. Yeah, let's try it again. What is pressure?
Did you say this?
And let me check.
You didn't do your last changes. The error was not in there. What was it?
Yeah. Okay, that's right. Okay, and let's comment the line to see what happens. Comment this, Okay, so the test is not passing because the precondition is met. And now we will see the other test. So we had another test for the empty function. And first we will try by passing all the, this is right. I mean the client is right. It requires a time. Okay. The time should be, the out variable should be open. And the in variable is closed by default. And okay, let's run this. It's failing because of the postcondition is not met. But now it's for now of the client that is calling the function, with the right info is follow the the supplier of the implementation. So instead of this, it should return this. Yeah, the error was the function was supposed to end the time, but the level was 1. In order to be ended, the level must be 0. And let's run again. And now all the tests are passing. So if you want to see the code or the library or the current progress of the library, that's the URL where we are publishing it on GitHub. I had to say that doing that was a bit hard in the start because the macros in elixir, you must be very, very careful, and in the start it's very, in my opinion, was a bit hard to understand how the macros work and what everything about coding and coding. Yeah, it was a bit hard, and I had to give the thanks to Chris McCord, the author of Metaprogramming elixir, because he was helping me a lot to understand the sample, and even like today 4 a.m., 5 a.m., and he was helping me to get this ready. So what we can do with design bar contract that is not done right now with the library, and would be nice to implement. We can do something like generate unit escape from the contract, or maybe we can also generate quick check test. What else? I think we can generate maybe dots, because the contracts are some kind of documentation also, and can help a lot to understand how the function works without having to see the full content of the function. And finally, I think that we can, for example, turn on and turn off the contract during development, or turn on during production if you don't want to get extra penalty in the application for the contract, or you can keep it in production if you want to have an extra level of protection in your application. And that's it.